Okay, so today we are doing, we're just working on the worksheet that is in OneNote. And these are just more complicated problems of what you did on homework, but they all kind of build on each other. And you will see at least one of these exact problems on the test. All right, so I'm not going to tell you which one, but just to hold your interest, you will see one. And they're too hard to make up, so I don't make up anything new. You can see one of these, okay, and other stuff too. But okay, so this first one is just about a fence that we're using area and fencing, but we're adding the cost aspect into it. So a fence must be built to enclose a rectangular area of 20,000 square feet. Fencing material costs $250 per foot for the two sides facing north and south, and $320 per foot for the other two sides. Find the cost of the least expensive fence. Okay, so we're not going to worry about north and south, all right? Let's just go ahead and label, the two shorter sides X and the two other sides Y. Okay, again, it doesn't matter whether, like, you get X to be one value and Y for the other. Yeah, that doesn't make any difference. Okay, so it must be built to enclose a rectangular area of 20,000 feet. So what equation does that tell us? Is 20,000, right? So we know, so again, that gives us the equation that we know that we have full values for, right? And then what about the cost equation? So the other thing is about cost, which is what we're going to try to minimize. So we know that fencing material costs $250 per foot for two of the sides. So what would that look like? Molly? There you go. Yep, 2 times 2.5x. And then plus the y. So 2 times 3.2 y. Everybody agree with that? Okay. So if we simplify that, first of all, 2 times 2.5 is what? 5x plus 2 times 3.2, 6.4y. Okay, now what's next? Right, so we need to rewrite, since this is what we're going to minimize, we need to rewrite this one variable. So, okay, so x equals 20,000 divided by y. Okay, and now we, again, use 20,000 divided by y to replace our x, right, in our cost equation. So we've got x equals 5 times 20,000 over y plus 6.4y. Okay, and then if I multiply 2 times 20,000 is going to be, or 5 times 20,000 is going to be 100,000. Plus 6.4 y, okay? Yep, everybody good? Okay, so now, can we combine these at all? No, the y on the bottom and y on the first. Okay, so now what's next? Derivative. So first, let's rewrite this, right? So let's make this 100,000 y to the negative 1 plus 6.4y. And now we take the derivative, right? So we get negative 100,000 y to the, what? Negative 2 plus 6.4. And now we do what? Well, we set it. So there again, even though I think you all know what to do, but But try to write out the steps, because I feel like setting it equal to 0 and then forces you to think about what goes to one side and what doesn't. Otherwise, you end up solving it in a weird way, and a lot of times your signs get messed up, okay? So actually set it equal to 0. And now, what would be easier to move at this point? Or the negative 100, right? Because then you can move it over and it becomes positive. Okay, again, it's just a way to, it wouldn't be wrong the other way, but then you're going to end up having to divide through by some kind of, by a negative. So are you okay if I go ahead and do all of this, right, at the same time? Okay, everybody good? And now, to get y squared up, we multiply both sides. And then we do what? Divide by 6.4. And y squared equals, and actually I did it the other way on my, what's it equal? Yeah, okay, I was going to say, it should be a good square. Yeah. Out of 15,625. Okay, yeah, okay. So it gives us 15,625, and then to solve for y, we take the square root. So all of these, as I said, should give you nice even numbers. So we get y equals plus or minus 125. Do we need to worry about negative 125? No, because again, these represents measurements, right? So we just want the positive 125. So if y equals 125, how do we find x? Yeah, plug it into the original equation, to the equation that we had with a value on it. So actually, and if you look at this equation, this is already set up to equal x, right? So we can say x equals 20,000 divided by 125, and that is, what we say, 160. Okay. Now, does that answer the question? No. So the question is, find the cost of the least expensive fence. So how would we answer that question? Plug it into which equation? This one? This one? This one? So part of, I mean, this we could do this one, but this one would be the easiest, right? The 5x. So if we take this cost equation and we plug in 5 times 160 plus 6.4 times 125. So if you plug that in, you should get, everybody try that. Huh? Mm-hmm. Is that what you got? Yeah, 1,600. Who got 1,600? Yeah, 1,600. What's that? Is that what you said? Oh, I thought you said 4,000 something. Did somebody say 4,000 something? Oh, did anybody else hear a different? All right. I swear it didn't sound like 1,600. Maybe because you said 1,000. Okay, sorry about that. Yeah, so 1,600. Katie's gonna think I'm nuts, but tell her I'm not, okay? Or tell her I am. Okay, questions about this? All right, so again, same kind of thing we just did, only we added cost into the equation, into one of the originals. Okay. All right, now let's try another one. Now, these are actually some of my favorites, but they're, okay, so now we're going to get into, so we're off of fencing and perimeters, all that kind of stuff. So 16 is packaging design. So a television manufacturing firm needs to, yeah, I'm going to skip 13. That's going to be part of your homework, okay? So 16 is going to be, okay, television manufacturing firm needs to design an open-topped box with a square base. The box must hold 32 cubic inches. Find the dimensions of the box that can be built with the minimum amount of materials. So when you think about it, we're building a box. Okay, so picture this is a box. This is not exactly square, but these are imagination. So it's a square box with no top. Okay, so if you look at it, it gives you this diagram that kind of shows, you know, here's the base, right? And then all of these represent the sides, you know, just forward down. Does that make sense? Okay. So we want to find, so, and we know it has to hold 32 cubic inches. So that is the volume, right, of a box, or of a box. And we want to find the dimensions. We want to build the minimum amount of dimensions. So they're talking about having the smallest box, right, that would still hold 32 cubic inches open topped, all right? So first of all, what is our equation that's going to have an answer to it, like our first equation? We have this 32 inches. So something's going to equal 32, right? What's that? No, let's go with the first one. So, well, first of all, if it's cubic inches, that means you're actually multiplying like 3 different periods, right? Or not 3 different ones, but you need an exponent of 3, okay? Cubic tells you that you're talking about 3 different values. So what do we know about the base of the box? It's square. So if one side is X, what's all the other sides? X. So if, but no, you were pretty much right. We're going to talk about it, you know, how to come after that. So the sides of the box, are they? They're not necessarily square, right? Only the base was square. So we don't really know how tall the box is. We know that the base of it is square, that the height of it may not be the same value, right? So we're going to give that value y. Does that make sense? So all of the box, the height of all the boxes, the sides is y. And what about this value? What would this value be? X, right? Because again, they are on a box like this side has to be the same as this side, right? Okay, so Kendall, so yeah, volume is going to be what? Right. Because again, when you think of volume of something, the formula for volume is length times width times height, right? But in reality, an easy way to think about volume is you're really taking like whatever area of the base is and multiplying it by the height, right? Because that's the same way as taking the area that, you know, taking all the way to the height, you're kind of taking what all the space is from the area that many times. Does that make sense? So think about it as area of the base times the height. So the area of the base there would be x squared, and the height would be y. Okay, so that's our equation we know. So now we want to find the dimensions of the box that can be built with the minimum amount of material. So when we talk about the material that all of these, so we're talking about how much cardboard it's going to take, right? And another way they talk about material is surface area, okay? Because we're basically trying to find out the amount of cardboard it would take. So we want to know from the area of this square, the area of this square. Does that make sense? That's telling you the amount of cardboard, right? So the area of these 1, 2, 5, 5 panels will give us how much cardboard. Okay? So who can tell me, or who wants to take a stab at coming up with an equation for the cardboard? Well, 5xy, so we need, so this is going to be xy, right? Oh, we're going to need, how many xy's are we going to need? Well, this is xy, this is xy, this is xy, and this is xy, right? And by xy, we're talking about the area of this square is length times height, right? That this one is going to be, what's the area of the base? X squared. Does that make sense? Does everybody see that? So we're trying to, so the area of this would be x squared, but the area of these, what's that? It'll be xy. Questions? Are you saying, all right, good? Okay. All right, so the equation, okay. This is not too hard. So, yes, you can, Beth, if you want to miss it. But no, so questions about it. Ask me some questions then. Does everybody see how the area of this square is x times x, right? So the area of this square is what? X times y. Right. Say that again. We're going to do 4xy. Yeah. So it's going to be 4xy. That takes care of all of the sides, right? Because this is an xy, that's an xy, that's an xy. Plus x squared. So here, let me. Yeah, this is hard, but this is calculus. So xy, xy, and xy. So we have 4 xy's plus x squared. No, it says there's no top. Yeah, so yeah, and that's where that becomes important. It's an open top box. Okay. Yes. Yep. Mm-hmm. Bingo. Yes. Did everybody hear that? If it was a closed box, if it had a lid on it, it would just be 2 plus 2x squared. Okay. So that is what we're trying to minimize. Okay. So what do we want to do next? Yeah. No. You're actually, it doesn't matter. But the way I did it, as I saw it for y up on the volume. Does everybody agree with that? So if we divide by x, let me do another column. So if we divide by x squared, we get y equals 32 over x squared. So we're going to take that, right, and sub it in for y. So now we're trying to minimize 4 times x times 32 over x squared plus x squared. Now, how can we simplify that? Catherine? There you go. And then what can we do with that even further? There you go. Does everybody agree with that? And then we also still get plus x squared. Okay. Questions about that? Again, all we've done, the exact same process we've done. It's just gotten a little bit more complicated equations. But we solved for y, we substituted y in, and then we're just simplifying this term. So 4 times 32, this is 128. We get x over x squared. That can reduce. Okay? And now we take the derivative. Actually, I'm going to come over here. So now we take the derivative. So first of all, let's rewrite this as 128 x to the negative 1, right? That's x squared. Then when we take the derivative, we get negative 128 x to the negative 2 plus 2x. And now we set it equal to 0, right? So how do we solve? Molly, question? Oh, go ahead. Okay. No. Well, so here I just wrote the equation and rewrote it because I'm getting ready to take the derivative. Okay, so I just brought this x up to the x to the negative 1. Okay, then over here, I'm taking the derivative. So I'm taking down the negative 1. I'm just trying to save room. So negative 2. Oh, sorry. Okay, so yeah, we're over here now. Okay, and I'm mixing it up on my screen. So what are we going to do? Set equal to 0. How do we solve it? Let's add the 128 x to the negative 2 to both sides. So we get 2x equals 128 over x squared, right? Brought that down. Now we multiply by x squared. Everybody with me? So we get what now over here? 2x to the third equals 128. Divide by 2. X cubed equals 64. How'd you do that? You didn't cube it. You took the cube root of it, right? So if we take the cube root, we get x equals 4. Does everybody know how to do a cube root on your calculator? Or, I mean, because that's going to come into this quite a bit. So yeah, cube root is just, you could do actually 64 to the 1/3 exponent is one way to take a cube root. Or you can do the math function where it says cube root. Okay? Okay, here, I'll show you. It's actually, it might be helpful for those at home. No. Well, no, because a cube root, like, it would be negative 64 would have a cube root of negative 4. Positive 64 is a cube root. Right. If it was, well, a negative taken to a 4th power would be a positive. But if you have a negative can be taken to an odd root, like a 3rd root, but a positive can't be taken to an odd root. That's where it's imaginary numbers. So for this one, if you do math, and if you go down to number 4 right here, and you type in 64, that gives you the cube root of 4. Okay? Or you could do 64 to the 1/3, also gives you the cube root. Okay? I'm Maddie. Yes. Okay, so x equals 4. So that tells us that the width of the sides of the base are 4. How do we find what y is? Yeah, so we come up here, y equals 32 divided by x squared. So 32 divided by 16 equals 2. So the height of all of our sides is 2. So when we're talking about the dimensions of the box, which is what it asked for, let's see, find the dimensions of the box. So one way to write the dimensions of the box is it is a 4 by 4 by 2 inches. Okay. Now, here's the thing too. One of these problems is going to be on the test. And don't just memorize the answers, okay? Because like if it were, and I've had that happen before, if it were this problem, you come up with like, oh, it's a problem for the two, you know, you don't get any credit, okay? You have to show me how to work. So, not that any of y'all would try to do that, but okay. Right, I'll have to get you the OneNote of the other two. We're doing these three in class. The other two are for homework, yeah. Yes, yeah, any of them are fair, and we'll go over them next class too. Because the base, so the base of a box is what height, width, and length, or width, length, width, and height. So the box represents the width and the length, and then the height is here. So because the box is a square, it's 4 by 4, and then 2 is the height. Okay, does that make sense? So anytime you're talking about a box, you need 3 dimensions, even though the 2 of them are the same because it was a square base. Okay? All right, questions about that one? Very good. All right, let's try another one. Similar. So we're going to do number 18. Oh, okay. Oh, we're here till 12:50 though, right? Okay. Yeah, I was starting to freak out that it was only had 5 more minutes. Okay. So a company wishes to manufacture a box with a volume of 36 cubic feet that is open on top and is twice as long as it is wide. Find the dimensions of the box produced from the minimum amount of material. Okay? So again, I highly recommend on this drawing a diagram, but this time instead of a square base, we have a rectangular base, right? Because it's twice as long as it is wide. So it looks more like this. That makes sense? So the base is longer than it is wide. So it's actually more like this. This is not a square, so it's longer than it is wide. But then again, the height has to be the same, right? Around the whole thing. Okay, so how can we label the box? X and 2x. So what would we give like this then? X and this would be 2x. Does that make sense? And then the height, y, right? Because that could be a whole nother. Okay, so I want you guys, I'm going to pause the video right now. I want you guys to try to come up with the 2 equations, okay? Okay, so let's look at the base right here. What is the area of the base? Lexi? 2x squared. Does everybody agree with that? Again, because it's just the side, so 2x times x is 2x squared. What about this one up here? What's the area of that box? 2xy. And the same down here, right? On this one, 2xy. If I agree with that one. And then, what about this side box? XY. If I agree with that. And that's how you want to do this, right? Don't try to, like, you might be able to come up with an equation right away, but what you really want to do, that's the purpose of drawing a diagram, right? Draw a diagram and take it just piece by piece. And then when I want to make my equation, I know I've got 2x squared plus 2 of the xy's plus 2 of the 2xy's. So again, it doesn't look really succinct right now, right? But that's basically what we're working with. That takes care of all 5 sides, right? And then, again, I want to look at that. I'm like, well, that looks kind of weird. So if I simplify it one more step, I can say, well, that's really just 2xy, and this is just really 4xy, right? And then I've got 2xy plus 4xy gives me 6xy. So don't try to jump right from 0 to 100 or whatever. Take it, build it step by step. Okay, so that is the surface area, right? So that's trying to find the dimensions of the box. So that, what do we set that equal to? Is that 36? 36 is the volume. Does this represent the volume? No, so we still need another equation. So this is really what we're just going to try to minimize, right? So what is the volume equation then? The volume has to equal 36. Huh? All right, Grace? Right, how did you get that? Right, so it's actually 2x times y. Does that make sense? And yes, it's 2x squared y. I just wanted to show how we got there. What's that? How? Okay. Right, so think of area of the base times the height. So x times 2x, and then times y. And that's right. Yep. God bless you. God bless you again. Okay, stop. Are you okay though? Okay. All right, so these are our two equations, right? Now we need to get a variable by itself down on this one. So let's, everybody okay with getting the y by itself? So we divide by what? 2x squared, right? So y equals 36 divided by 2 is what? 18 over x squared. So far, so good? So now what do we do? Right, substitute it. So we take this y and put it in for this one, right? So now our minimized equation becomes 2x squared plus 6x 18x squared. And there again, I highly recommend showing it like I do. Like, I'm not trying to combine anything right now. I'm purely just taking one equation and substituting in the value in the next one, okay? Now, to clean that up, I keep my 2x squared. And what can I do with this next term? 16x by 18 gives me what? 6 times 18 gives... 6 times 18 is 108 over x, right? Because x over x squared gives us x on the bottom. All right, so now I'm going to rewrite that. And now I take the derivative. I get 4x minus 108 x to the negative 2. And I set it equal to 0. Now I move the 108, right? Multiply by x squared. So I get 4x to the third, right, equals 108. Divide by 4, and I get x cubed equals 27. So if x cubed equals 27, x equals 3, right? So if my box has a base, so if x is 3, so that represents the width of the box. The length is what? 6. And the height, let's see, we plug into this right here, right? I'm sorry, what's that? Sorry. Okay, so the width of the box is x, right? Then the length of the box is 2 times x. So the width is 3, 2 times x is the length, and then the height is 18 divided by x squared. So there again, my box is 3 by 6 by 2. Wasn't that fun? But now, you have to acknowledge, so like this would be something you might need to do. Like it would be helpful information if you were in product development and you need to try to find a box and you need this amount of room. Get out your old calculus note. There's no computer program that could do that for you, I'm sure. But yeah. Right. No. And actually, you'll never, because even on that cost one, we didn't have to plug it into the minimum, right? We plugged it into the one with an answer. Or no, you're right. Cost, we did have to plug it in. Yeah. Yeah, just make sure you answer the question. So the final answer is 3 by 6 by 2. I think it's cubic inches. Is that right? Cubic feet. Right.